Okay, let's talk a little bit now about calculating weld strength. So you can see from here the fundamental equations for the base metal and the weld metal. A lot of times if we have weld metal that's kind of matched well with the base metal, we don't really need to check this, but we can, and it's worth doing. And it really is a function of what is the strength of the base metal times the area of the weld interfacing with the base metal. And then for weld metal, the nominal strength, so R sub n, and this capital R would be the full strength of the completed joint. I like to use a lowercase r when I calculate weld strength per inch. Anyway, the weld strength is a function of the weld metal strength times the area of weld. Very simple. And then these values, base metal strength, weld strength, and phi, are from the tables. So these are the tables that I'm talking about here. So if I look at fillet welds, do I have that? Looks like I don't. So you'll need to jump over to the fillet weld table in the code to calculate that. So just deeper into here. All right, so basically for um, let's say we're designing a partial joint pen groove weld. So we have tension to the axis, normal to the weld axis. Our base metal strength is sorry, I'm getting kind of distracted. Base metal strength is the ultimate strength of the base metal. The weld metal strength is 0.6 times the specified weld strength. So this FEXX, we choose that and we put it in the general notes. Generally that's 70 KSI, 60 and 80 KSI weld metals are available and are perfectly fine to use. The phi factor in this case is 0.85 omegas for allowable stress design if we're doing that. So I can basically take, in this equation, my weld strength is going to be 0.6 times what I've specified it as. All right, effective area of the weld is going to be the throat thickness times the length of the weld. I think I've got an example. Yeah, so if I come here, if I have a fillet weld, my effective throat thickness is going to be 0.707 times A, which is just cosine of 45 degrees in this case. If my weld happens to be wonky like that, then my effective area is calculated by that thickness, or this equation. Okay, so backing up, basically look at the geometry of your weld to find the area. Weld strength is based on this table. Okay, so there's some minimum requirements for partial pin welds, pen welds, plug welds, requirements there. For fillet welds, I wanted to get into those minimums because they're very common. So if I have a 1/4 inch or half inch to 3/4 plate, I need a minimum of a 1/4 inch weld. And then there's also a maximum on the weld side. And that's shown in this table here, or this slide here. So if I have less than 1/4 inch material, my weld can go all the way to the edge. If I have more than 1/4 inch or equal to 1/4 inch, my weld needs to be a 1/16 smaller than the plate thickness I'm welding to the edge of. And that's to keep this corner from melting and just kind of flowing into the weld. So for small welds, there tends to not be enough heat for that to happen. Larger welds, there does. Oh, here's the fillet weld table. So you'll need this for some of your submittal stuff. So phi of 0.75 on the weld, 0.6 FEXX for the strength. Not sure why those slides are so far out of sequence. Okay, a couple examples from drawings of welds. So here would be a double-sided fillet weld. So this clip occurs on the near side that you can see and also the far side that you can. And then this says weld on 3 sides, which means weld here, here, and here. And then this particular joint had a web doubler because the forces were so high in this connection. And so basically I've said take this plate, add it, and then weld all the way around. Now something you'll notice is here I'm calling out a fillet weld around, but when they get to here it's going to turn into a butt weld. So sometimes this causes a little bit of confusion where you go from an obvious fillet weld to a butt weld. Generally folks are capable enough to figure that out, but sometimes it's confusing enough that they'll ask a question, and that's fine. Here's a heavy moment connection. So in this case, I've called out a full pen weld, and I've shown the joint prep on the drawing. Usually you don't need to do that. I like to just call it out as that symbol and then allow the shop to decide how they're going to make that full pen joint based on their shop practice. And then over here, the stiffener, I've full penned on one side, but here and here I've done a fillet weld based on this information. And the thickness is here in the table so they can calculate that. Here's an example of a brace frame connection. So weld here between the gusset and the beam, weld here between the clip angle and the gusset. This brace could also be welded in place. Generally braces in the field, if we bolt them, it makes life easier, but doesn't mean you can't field weld braces in. It's done all the time. All right, so that wraps that up. Really quickly, I wanted to walk you through this weld example. So what I've given you as the problem is this joint was called out to be field bolted, but say there is some fit up error, say they made this angle wrong and the holes didn't quite align. Basically the contractor calls you, says, hey, we're running out of time to install this brace, give us a weld option. And I assume that there's no access to the calcs. And so rather than worrying about that, I say, well, there's 3 bolts. So if I take the full bolt strength and design for that 54 kips, then I'll have enough strength. Then on this page, I basically walk through the calculations to calculate at the end of the day, oops, wrong symbol, that I need 12.8 inches of weld. So I go back on this image, mark that up, and I can give that to them. Sometimes we'll weld the end. Welding this portion, I think, isn't the greatest idea because it can undercut into that brace. But sometimes there's reasons to do that. All right, so that's the example for the fillet weld. You can actually use this calculation example to find your fillet weld strength. I actually like to use a table, and I'll pull that up here for you and talk about that. So I like to use this table here in my work, probably the most common size of welds I specify are 1/4 and 5/16, and this basically gives me the phi and little r, so kips per inch of different sizes of weld, different strengths, different sizes. And what I can do with this, if I know the force coming into my joint, I can say, okay, say it's 150 kips, I can divide that by the 6.96, get the length, and then figure out how to make that length of weld lay out properly in the joint. Okay, so that's that. I will talk to you more in class, and certainly come with questions so we can chat about them.